Welcome to another episode of Plot Conversations from Thrombosis Canada. I'm David Airdrie, Executive Director.
I'm Jamil Abdul-Rahman, Hematologist from Toronto General Hospital.
We're here to provide you with updates on diagnosis and management of thrombosis, featuring interviews with authors of recent research publications and highlights of education programs from Thrombosis Canada. Thank you for joining us for this episode.
In this episode, we'll be discussing a recent paper published in Blood Reviews entitled No Apparent Association Between mRNA COVID-19 Vaccination and Venous Thromboembolism, and co-authored by a national team of Canadian experts. We're joined today by two of the authors, Dr. Matthew Nicholson and Dr. Noel Chan. Dr. Matthew Nicholson is a clinical hematologist at the Saskatoon Cancer Centre and an assistant professor in the College of Medicine at the University of Saskatchewan. He obtained his MD and Internal Medicine residency at the University of Saskatchewan in Saskatoon. Dr. Nicholson completed his hematology fellowship training at the University of British Columbia in Vancouver and completed a clinical fellowship in thrombosis medicine through McMaster University, and is board certified in Internal Medicine and Hematology. Dr. Nicholson has acted as an advocate for improving training conditions for medical students and residents during his time with provincial health organizations and the Resident Doctors of Canada Board. He co-authored the Resident Doctors of Canada Data Collection and Learner Privacy Principles, which has been adopted to help govern learner privacy rights in medical colleges and medical licensing bodies across Canada. His research interests include venous thromboembolism, thromboprophylaxis, and hemophagocytic lymphohistiocytosis. And Dr. Noel Chan is an assistant professor in the Division of Hematology and Thromboembolism, Department of Medicine, McMaster University, Hamilton, Ontario, Canada, specializing in anticoagulant therapy and thrombosis medicine. His research seeks to improve our understanding of the triggers for thrombosis, including the role of inflammation, and the determinants of variable response to antithrombotic therapies to inform novel strategies with the potential to future reduce the burden of thrombosis. Thank you for participating in our podcast today.
Thank you, Jamil, and thank you for your kind introduction.
We're really pleased that you could join us, and I'd like to start by asking, why did you and your colleagues feel there was a need to write this review?
Yeah, David, as Noel said, thank you so much for having us on the podcast. This review was a passion project of mine, and I was very fortunate to have a brilliant team of writers and researchers, Noel Chan, who's with us, Deb Siegel, and Hattie Gubran. And we've all been just really pleased, and I've been very flattered with the positive reception our review paper has received this last few months. I spend the majority of my time in direct clinical work, and the question that this review seeks to answer is a question that both at the time we started this process until now is still being asked to me as a hematologist and thrombosis specialist very frequently. There was a lot of specific attention in the spring of 2021 devoted to the association between vectored vaccines, AstraZeneca and Janssen. And there what we saw was this real and causal relationship to a rare but serious blood clot disorder that's been established under the term vaccine-induced immune thrombotic thrombocytopenia, or what has been come to known as VIT, and the administration of those vaccines. Now, somehow this understanding of VIT became an understanding in patients and practitioners that all COVID vaccines, including the Pfizer and Moderna vaccines, were causing blood clots. I remember a very specific moment in about November last year, getting a text from one of the best internal medicine specialists at the hospital I'm at now, saying how long after a Pfizer vaccine would we no longer consider a new PE to be caused by the Pfizer vaccine? And so the whole premise of this question was that this was a done deal, that these vaccines caused blood clots, and all he really wanted to know was how long that risk was expected to persist. It was sort of at that point that we decided that a synthesis of the available knowledge on this subject would be a useful contribution, both for thrombosis specialists, but also for clinicians everywhere, and that a review which clinicians could find quickly in the clinic or even direct patients to that seeks to answer this simple question, whether the mRNA vaccines are associated with an increased risk of venous thromboembolism would be a useful thing to do. It's also quite important in the clinical management of VTE or venous thromboembolism to be able to determine what constitutes a risk factor, because it's the clinical context and the risk factors that were present at diagnosis that become later the key determinant of the risk of recurrent VTE, and therefore become quite important in counseling our patients, making a recommendation about the net clinical benefit of ongoing anticoagulation. So in my mind, there's these two questions. First, the question of whether these vaccines are a strong risk factor for VTE. That ties in very directly with folks' decisions about whether these vaccines are safe, but also this practical and potentially highly impactful decision of whether patients in my clinic and many others should continue with anticoagulation beyond the initial treatment period.
Yes, and same for me as well. So we felt that there was a need at the community level to address misinformation about mRNA vaccination. and venous thromboembolism, and the need for accurate and up-to-date information for our own patient and a referring physician. So I think it was only natural to conduct this review as we wanted to find as definite an answer as possible to the question of whether there is an association between mRNA vaccine and venous thromboembolism. So we figured out that the answer would be important for us and others, and writing this review was also an opportunity to distill and disseminate the evidence for use by other healthcare professionals.
So can you provide our listeners with a brief overview of the association between the mRNA vaccine and venous thromboembolism?
Absolutely. Let's first, just before we do that, put things in context by discussing very briefly the very high risk of these types of clotting events that we see with COVID-19 infection, particularly severe COVID-19 infection requiring hospitalization and supplemental oxygen. And that as we learn more about longer symptoms of COVID, the long-term effects of COVID, we find that individuals who had a severe COVID-19 infection continue to have a relatively high risk of these and other types of blood clots. It's certainly highest during the infection, but that risk appears to persist for quite some time. I just finished reading a review in Nature Medicine that estimates an excess absolute risk of venous thromboembolism of about 1% over the next year after a severe episode of COVID-19 infection. Meaning that in addition to those who experience a blood clot right away when diagnosed with COVID-19, we'll continue to see increased rates of VTE in our communities, up to one extra VTE event for every 100 people diagnosed with a COVID-19 infection. And given the number of people out there in our communities now who've had a COVID-19 infection, this represents a substantial public health burden in the form of increased cases of VTE, arterial clots, heart issues, and other consequences of those infections themselves. Now, what you actually asked was about the association that we looked into, which is between the vaccines that we studied, the mRNA-based vaccines and VTE. And here we have good news. The broad overview is that these mRNA vaccines developed during the COVID-19 pandemic do not appear to show any association with an increased risk of VTE in stark contrast to the risk of the infections themselves.
Okay, great. So the review focuses specifically on the mRNA vaccine, so the Pfizer and the Moderna. You mentioned a bit earlier about the VIT, which was seen with the AstraZeneca and the Johnson & Johnson vaccine. Could you tell us a bit about the VIT and how that's different from what we've seen with mRNAs?
Sure. So just to provide context here, and similar to what Matt just said before, I think it's important to point out that the overall risk of blood clots from the adenoviral vector vaccine is relatively small compared with the risk associated with COVID-19. So the AstraZeneca vaccine rollout occurred early to 2021 in the UK, and by March 2021, several countries, including the UK, the European Union, and Scandinavia, began reporting an unexpected increase in the case of uncommon thrombosis. So typically including cerebral venous sinus thrombosis, splenic vein thrombosis, which was associated with thrombocytopenia in a small number of individuals, typically younger age individuals who received the AstraZeneca or the Covishield vaccine. Subsequently, similar findings were observed with a small number of individuals who received the J&J vaccine. And this syndrome has been designated vaccine-induced immune thrombotic thrombocytopenia, VIT. VIT is rare with an incidence ranging between 1 in 26,000 to 1 in a 250,000, and is caused by antibodies that recognize platelet factor 4 bound to platelet. So it's one of the rarer causes of thrombosis, which is immune-mediated thrombosis. So these antibodies activate platelets and also activate other cells, including monocytes, that results in marked coagulation activation and clinically significant thromboembolic complications.
Great. Okay, so it sounds like the risk of VTE with COVID itself is astronomically larger than the risk of VTE with the AstraZeneca or the Johnson & Johnson. Is that accurate?
That's fair to say. I mean, if you look at the data, you would see estimates of increased risk of anywhere between 9 to 12-fold with COVID, whereas with AstraZeneca or the Covishield vaccine or the J&J, this risk is significantly less than 9 to 12-fold increase.
Perfect. Okay, great. So going back to the mRNA vaccines, why is it so challenging to answer the question of whether they increase the risk of VTE?
So yeah, initially it seems like it's going to be a simple question, but it turns out to be quite a complex endeavor for a few reasons. The first is that the phase 3 randomized control trials just are not powered to detect differences in VTE. They're trying to look at efficacy of those vaccines, and the number of events is too small to draw really definitive conclusions. And the second, that observational studies which report VTE event rates after vaccination could theoretically be compared directly to known background rates of VTE, but this approach has a number of really stringent limitations, including the typical limitations of observational studies, confounding by imbalances in population characteristics, that rates of VTE tend to vary extremely widely based on age, region, genetics of the population studied, not to mention the presence of secular trends over time. More generally, we know that over 1 billion doses of these mRNA vaccines have been given, and we know that unprovoked VTE without other identifiable risk factors are a relatively common occurrence, such that by coincidence alone, we're going to see some VTE events happening shortly after mRNA vaccinations. So in a way, what you want is not to determine whether any VTE events occur after vaccination. The real question, the more challenging question, is whether the number of observed VTE events shortly after mRNA vaccine administration exceeds the number that we expect to see.
So I thought one of the really helpful things about the review was you broke down the results by the different study types. But looking at the RCT data, what can you tell us about the association between mRNA vaccines and VTE?
Oh, so you're right, Jamil. So we looked at 3 different sources of data. So randomized controlled trial, observational data set, and also pharmacovigilance data set. So focusing mainly on the randomized controlled trial data. So the trial of the Pfizer mRNA vaccine involved about 45,000 participants who got administered almost 37,000 doses of vaccine. And for Moderna, this trial included over 30,000 participants receiving over 28,000 doses of vaccine. So in both trials, the VTE incidence were low, less than 0.01% in both arms, and there was no significant difference between intervention and placebo. So I think the reassuring finding here is that the incidence rate of VTE were low, but if you're looking at a rare complication, for example, that occurs 1 in 100,000 or 1 in 10,000, so trials with sample size of 40 or 30,000, they are not going to be designed to be able to detect differences in these types of complication. And that's why there's also a need to look at the COVID data set, including observational data and pharmacovigilance data as well.
So what can you tell us about the observational data and the pharmacovigilance data?
So as it pertains to the observational data and some of the pharmacovigilance data, we looked at a number of analyses which were already quite good and quite complete, where authors had already looked at analyses using the VAERS data, the FAERS data, and the Eurovigilance data. And so we saw, firstly, in the States, an analysis of women under the age of 50 through VAERS and FAERS, showing a relatively low rate of reported VTE. There's a terrific analysis of some of the European Union data, looking at an intelligence analysis to show that arterial events and venous events that were being reported after these vaccines were all happening at relatively the expected rates, but also increasingly the expected proportions to one another. Without going into a ton of detail, the analyses which had already been completed on these databases seem to show that the events being reported fit the expected pattern of events that we should see in these older populations who were most often vaccinated first. In contrast, we did see in some of these same analyses, they looked at also the vectored vaccines. And after the AstraZeneca vaccination, these same analyses showed a greater number of venous events than would be expected, particularly compared to arterial events. So instead of reporting about a 3-to-1, about 3 arterial clots for every venous thromboembolic event, they were seeing about 1-to-1, indicating this possible increase in the risk of venous thromboembolism after the vectored vaccines. Now, when we talk about the observational data, there's quite a bit to go through, and perhaps it's just best in many cases to look at the paper, but I'll try to summarize as best I can. There's a fairly robust and interesting set of data generated from the observational set that can help to answer this question of whether mRNA vaccines can be linked in association or causation of VTE. And I hope I can impress upon you 2 points that might initially seem contradictory. The first is that observational data is just deeply imperfect, and it cannot generate the level of certainty that a randomized experiment can. And that secondly, the observational data here produces an estimate of association which is tightly clustered around an incidence rate ratio of 1.0. There's not a lot of variation. The strengths of the methodology here with what we're going to talk about, these self-case control studies, the tight clustering of the estimate, in combination with the randomized data and suggestive data from the pharmacovigilance databases, provide us with a relative confidence that the observational data in this case is producing a result which is as accurate as possible within the known limits of observational data. Now, when it comes to the specific data, the method which we look at most commonly and that we see the largest sets with is known as the self-case control method. This is where you have a very well-defined and documented date of exposure, and then one can apply a type of observational study design that uses vaccinated individuals as their own control group by examining an equal period of time shortly before and after vaccination. This approach avoids significant confounding by controlling implicitly for all fixed confounders underlying characteristics like genetics, location, socioeconomic status, frailty, that are extremely difficult to identify and match for in other large observational sets, and that in other types of observational studies can still cause problems even after attempting appropriate propensity score matching. Now, without getting too far into methodological details, the self-case control series was actually developed in response to concerns about vaccine safety, in response to concerns with a particular mumps strain, which was causing aseptic meningitis in a period of 15 to 25 days post-vaccination with MMR in the UK. And it was based partly on the evidence provided by these same types of observational studies that the composition of the MMR vaccines in the UK was changed. In our case, a review of the analysis and strength of the conclusions come from the variations on this type of case control analysis. This is performed by researchers in the US, England, Scotland, France, and Israel, and applying these self-case control designs to large populations of individuals receiving these vaccines. In many cases, those analyses looked not just at VTE, but a wide variety of other rare but serious adverse events after vaccination. What our review does is extract and compare the specific data on rates of VTE from these larger analyses wherever they exist. Now, what you end up with is a set of well-constructed studies with designs to minimize confounding, using different baseline populations in different countries, using different time frames ranging from 14 to 90 days after vaccination, and ultimately representing an impressive more than 20 million doses of these vaccines. And they all found very, very similar point estimates of risk, which cluster at or below an incidence rate ratio of 1.0 after vaccination, indicating no difference. To put it very simply, there were statistically the same number of people who were diagnosed with DVT or PE in the month after receiving an mRNA COVID vaccine as there were folks diagnosed with a DVT or PE in the month prior to the vaccine being given.
Just one more point to add. So we examined 6 large observational studies that provided data on 22 million administered doses. And in each of these 6 studies, we consistently found that the rates of VTE in the post-vaccination periods were no different from pre-vaccination periods. So it's really the consistency across the observational studies as well that provides some degree of strength towards our conclusion that there was no evidence supporting an association between mRNA vaccination and VTE.
Okay. So if we put the VIT group aside, so there's a large proportion of the population has been vaccinated. So from chance alone, we will see patients with the temporal association between their vaccine and their VTE. Many patients may feel that because of the timeline, their VTE is a result of their vaccine. How would you approach this scenario, and how would you discuss this with your patient?
Well, you want to go first or me first? I think we should both try to tackle this one.
Yes, I'll have a go. So this is an important, but also, I think, a challenging issue. And one potential approach is to engage and listen to the patient. So why do they feel or perceive that vaccination is the cause of the venous thromboembolic event. I think this step would help identify information voids or misinformation or gaps in the understanding. And certainly one of the issues that commonly arises is this issue of temporal association. If A occurs before B, then A must be the cause of B. And doing this review provided us with information to show that VTE rates before and after vaccination were no different. And therefore, sharing accurate and clear information may assist in pointing out misinterpretation or misinformation and replacing these with a correct understanding. And perhaps this could help, improve, our treatment approaches to patients.
I completely agree. And maybe because I've had great teachers like Noel, but I think that approach of really wanting to dig in, explore exactly what the concern is, what made them think that these two events, vaccination and VTE, were related in the first place, because folks do come at this from very different places. I've been surprised that this is probably less of an issue in my clinic than I would expect. With a lot of folks, I found that it's enough just to say that the best available evidence does not suggest that these vaccines are associated with these types of blood clots, and combine that with the information that a lot of the time, around half the time, we just don't identify any clear reason why somebody develops one of these types of blood clots. We call that unprovoked VTE, and that for better or worse, they're in good company. There's lots of other folks where this just comes out of the blue. I think part of what your question gets at, and the really challenging scenario, is just to acknowledge that there are some folks out there where you're going to have to agree to disagree. We're just so hardwired to identify that cause and effect relationship that Noel was speaking about. I really don't blame folks if they've never had a COVID vaccine or a blood clot before. All of a sudden they get their first dose, and 1 week later they have their first episode in blood clot. In some ways, it feels like sharing the data that we have here is also that we're asking people to ignore the evidence of their eyes. We know now that that person was just as likely to have a clot the week before they got the vaccine as the week after, that the cause and effect relationship that we appear to see in some of these cases is fallacious or coincidental. But I do really empathize with folks who have trouble seeing that, and sometimes you just have to leave it at that.
So what are some of the concerns with misinformation or misconceptions about the safety of vaccines?
Yeah, I think Noel was already starting to go into this. There's probably two specific points from the review that really help to avoid what he's describing there as this post hoc, ergo propter hoc, informal fallacy and attribution of these VTE events to the vaccine. Again, just going over this, that the data acquired up until this point seem to confirm you've got an equal number of VTE events leading up to the days where this vaccine is given as in the days after. And secondly, that there's quite a few folks who have one of these blood clots in an unprovoked fashion or out of the blue. In the paper, we talk about a couple of very, very rare exceptions to this, where we think there may be an association between these mRNA vaccines and certain upper extremity thrombosis. And we also talk about what we can do in a limited way as clinicians and scientists to try to avoid unnecessarily generating association fallacy. There are all of these publications, media reports out there with some sort of a banner headline about blood clotting caused by vaccination. And I think that you contribute in some way when we do this to association fallacy, that all blood clots that all vaccines lead to blood clots. And by being specific in these cases about which vaccine is being discussed, rather than talk about vaccines generally, we might hope to avoid this in some degree. We do talk about this, including these biases, a bit in the paper, how our sort of natural biases lead to these kinds of misinformation, misconceptions in both patients and practitioners, how we hope to address this in the future, or really any of the data that we talk about today. It is all up on blood reviews, and it's all open access. So if you're more interested in that, then feel free, of course, to check it out.
So is there anything else that you'd like to add that we haven't covered in our discussion today?
I'll maybe share something that I thought was interesting. I was listening to a podcast, an interview with Paul Offit, a pediatrician in the US recently, and he said something that really resonated with me, that we tend to overrate risk from something that you do and discount risk from something that you don't do. And not doing something, in this case, not getting vaccinated for those folks in a region with a high burden of COVID-19 disease, you're taking on a significant risk of severe disease and potential for long-term adverse effects from having had the disease without the protection that we know exists from severe disease from these vaccinations. I think the goal is always to take a lesser risk. And I think it's quite clear at this point to me that the lesser risk is to be vaccinated. As a scientific community, we can do more. We probably should do more to help synthesize and convey what we've learned, what we know, and what we don't know about the safety of available vaccines. And akin to what happened back in the UK with MMR vaccines, where there are areas of improvement that we can help to drive that improvement. I want to get out there and help folks understand what the potential risks of any choice that they make is. And on that note, I want to thank you, David and Jamil, for having us on the podcast and helping to be a part of that effort.
It's been our pleasure. We've really enjoyed your presence and participation today in the podcast. And I'd like to thank our listeners for joining us for Clot Conversations from Thrombosis Canada. We welcome your comments, questions, and suggestions on the podcast. And if you have any recommendations for future podcasts, please send them to us at info@thrombosiscanada.ca. Please subscribe so that you are notified about the release of new episodes. And don't forget to check our website for education programs, clinical tools, and guides. And also, please consider donating to Thrombosis Canada to support our ongoing efforts to reduce morbidity and mortality due to thrombosis.